So online, are you able to hear?
Yes, sir.
Are you able to see my screen?
Yes, sir.
I asked what are all the questions that you have doubt in 6.2.
No doubt, sir.
No doubt. Huh? Okay. So listen, 11, let's see how to solve. Prove that the function f given by f of x is equal to x square minus x plus 1 is neither strictly increased nor strictly increasing on minus 1 to 1. So f of x is equal to x square minus x plus 1, which implies f dash of x is so 2x minus 1. So this implies for increasing, what should be the condition? Increasing means strictly increasing only. F dash of x should be, meaning x should be greater than half. So for decreasing, what should be the condition? Which implies x should be less than half. So what is happening here? So minus infinity to half, it is decreasing. And from half to infinity, it is increasing. So what is happening between minus 1 to 1? Because this is the domain, how it is falling. Between minus 1 to 1, what is happening? This number will fall, no? At some points it is decreasing, at some points it is increasing. I'm assuming this is one doubt you had. Right? Shall I proceed? Okay. What are the question? 15th. Someone told. 15. This one only, no? Right? Okay. Let I be any interval disjoint from minus 1 to 1, where minus 1 and 1 are included. So what is going to be the domain? From real number, you need to remove minus 1 to 1. Prove that the function f given by f of x is equal to x plus 1 by x is strictly increasing on I. So f of x is equal to x plus 1 by x, which implies f dash of x is how much? 1 minus 1 divided by x square. Right? So for increasing, what is the condition? For increasing, f dash of x should be strictly greater than 0, meaning x square minus 1 divided by x square should be greater than 0. So one thing I'm clear is, from the real number, when you removed all the numbers between minus 1 to 1, x is definitely not equal to 0. Why? Because 0 falls between minus 1 to 1. It is not a part of this particular domain. So when x is not 0, what I can do is, I can multiply with x square on both the sides, meaning the x square can go to the other side. Hence, you will have x square minus 1 alone greater than 0. Then what will you have? You will have x minus 1 into x plus 1 is greater than 0. So x minus alpha into x minus beta is greater than 0. Then x belongs to minus infinity to minus 1 union 1 to infinity. So this is an interval where the function is increasing. And this is the domain of the function also. Right? Hence, we have proved that this given function is strictly increasing on the domain of the given function. Clear? 100. Right. What is the question? 16 done? Done now? 17? 18? 19 is also done. 19th. Okay. So first differentiate this and show me. Differentiate it and show me. 2x to the power minus x. That's it. 2x into e power minus x plus e power minus x into minus 1 into x squared. You get the answers. What is the derivative of this? F dash of x is equal to minus, okay, minus e power x into x square plus 2x into e power minus x. So e power minus x into minus x square plus 2x. So minus x square plus 2x. So for this function to be increased, right, for this function to be increased, e power minus x into an algebraic function, that is an exponential function multiplied with an algebraic function, is greater than 0. And remember, exponential function by default is always positive. Why? Because if you observe the graph, this is how the graph for e power x will be, and this is how the graph for e power minus x will be. Okay. So this e power minus x and e power x both are positive. Hence, you have nothing to do with this. This can be taken to the other side. So if you take the x outside, you will have x into 2 minus x is greater than 0. So x into 2 minus x is greater than 0. Or I can write x into x minus 2 is less than 0. Can someone tell me what I did there? I took the minus sign out. When minus sign goes to the other side, inequality changes. So x into x minus 2 is less than 0. X belongs to 0 to 2. Is there an option? Is that? Got it? So the only fact that you need to know is you need to understand about exponential. So one common mistake that happens is when we see e power minus x, people think that it is negative. Whenever you have e power anything positive or negative, it is always positive. And one more thing is, if suppose there is a 1 mark question where they are asking about the exponential functions. Okay, so if they ask about e power x, and they ask you the interval where the function is increasing. Suppose the question is y is equal to e power x, and they're asking you define the range in which, range in the sense the value of x for which this function e power x is increasing. It is real number. I told you, that is where we get confused. E power x graph from minus infinity to plus infinity is always increasing. Whereas if they ask y is equal to e power minus x and ask you, if they give you y is equal to e power minus x and ask you the interval in which the function is increasing, what will answer be? Where will the function e power minus x increase? Nowhere. Please concentrate. E power minus x, where is it increasing? It is decreasing. Okay, there is no interval in which e power minus x is increasing. Similarly, there is no interval in which e power x is decreasing. That is the point to be understood. Are you able to understand? So we discussed about exponential logarithmic function in the previous chapter, but this is the point I wanted to make. So three things. When I talk about y is equal to e power x, what is the domain of this function? Real number. What is the range of this function? What is the range of this function? It is 0 to infinity. You will never get 0, you will not get infinity also. Okay. Similarly, they say y is equal to e power minus x. Domain is real number. Range still 0 to infinity. So range will decide whether the given function is positive or negative. Negative. Got it? Shall I proceed? Shall I start the next exercise? Now, with respect to the applications of derivatives, first thing that we saw was rate of change of physical quantities, right? 1 minute. So first thing that we saw was rate of change of, guys don't talk, and talk later. Yeah. So we saw rate of change of physical quantities. Then we saw the concept of increasing and decreasing function. Now the last and the most important one is maxima minimum. Okay, this is the main reason why we are studying it. Okay, what is it called as? It's called as maxima and minima. Okay, so as the name suggests, right, it is very simple. Maxima is the plural of maximum. Minima is the plural of minimum. Also, when you think of a function, right? So there are different ways in which different functions behave. For example, if I give you the graph of e power x, it is going to be like this. If you observe, it is a monotonically increasing function. Means it is not having any ups and downs. But there will be certain instances where you will have functions which have ups and downs like this. What is this? So this is a graph for y is equal to sin x. So whenever you have a question of up and down, that is within the same function, in the domain of that function, if the function is increasing and then decreasing, right? So according to the previous exercise, we say that the function is neither increasing nor decreasing in the given domain. But when that kind of a behavior is established, then the first point to be noted is the function has a point of maximum or it has a point of minimum, right? If you observe, this function has multiple maximum, right, which is called as maximum. It will have multiple minimum points, which is called as minimum. Now our job is to find the points at which this maxima or minima occurs. So it is very simple, okay? It is almost similar to the previous exercise, except the fact that in the previous exercise, when someone asks you about increasing or decreasing function, you find the range of values. You find the interval in which the function is increasing or decreasing. It is not one value. Whereas when you talk about maximum or minimum, it happens at a particular value. Okay. So there are two things that they will ask you to find. One is the x value for which the y value attains maximum, and what is that maximum value. So are you able to understand? Find, they'll ask you a question like this. Find x where function attains maximum. Find x where the function attains maximum. And second is, they'll ask you what is the maximum value. So all that you're supposed to do is you find the value of x where the function attains maximum, take that and substitute in the function. That will give you the answer. Okay. Similarly, you can reverse the case with minimum. So this is what all that we need to do. This is all we need to do with respect to maximum and minimum. I hope you're able to get a perspective out of it. Right. Now the question is, okay, I understood from the graph that if something is increasing and then decreasing, I have a point here which I can call it as maximum. Similarly, if the function is decreasing and then increasing, I have a point which is minimum. Then how are we going to use the applications of derivatives to actually attain the point of maxima or minimum? Okay, that is what we are going to see. Okay, now observe. When I talk about a function like this, so this is there, from here drop a perpendicular. So this point, if I call it as c comma 0, where c is the point at which maximum value is attained. So question is, what is happening on the left of c and what is happening on the right of c? So on the left of c, if you see, when you draw a tangent like this, right, the tangent drawn anywhere before c on the left of it, okay, then what will happen is the tangent always makes an acute angle. So when tangent makes an acute angle, what can you say about the slope? So what happens on the slope? What happens to the slope of the tangent on the left of point C? What happens? It becomes positive. So f dash of C minus is positive. Similarly, if you draw a tangent on the right of C, then if you observe the angle made by this line with the x-axis in the anti-clockwise direction, let me call this as alpha, then alpha is obtuse. When it is obtuse, the slope of this tangent will always be negative. So what happens to the slope on right of C? F dash of C plus will be negative. So if I take that point C and consider the left hand derivative and the right hand derivative, if the left hand derivative, if the derivative from LHT to RST changes from positive to negative, if it changes from positive to negative, then the function is said to attain maximum. Then the function is said to attain a maximum at which point? Maximum at the point C, that particular point C. Are you able to understand this? Right? Similarly, if you observe the case of this kind of a function, let's say this point is C comma 0 again. On the left of C, if I draw a tangent, anywhere you want, you can draw on C. If I draw a tangent, it always makes an obtuse angle. So what will be the slope of this? F dash of x will, F dash of C minus will be less than 0. Okay. F dash of C minus will be less than 0. If I draw a tangent on the right of it, I'll get alpha, where alpha is going to be acute. Then the slope of this F dash of C plus will be positive. So if the slope, I repeat, if the slope changes from negative to positive, right, then it is said to have a point of minimum at C. Then it's said to have a point of minimum at C. Okay. So this is one way of testing. There is another way also. First, what you can do is copy this, then I'll explain what is the second method. So where are others? They left, they went home. Inuma. So those who wanted to attend that 7 o'clock, how do you? Okay. 7 o'clock when you can be there. Those who want the first batch, those who missed it, you can be at 7 o'clock if you want. I mean 6 to 7. Those who are online, I hope it is clear, no?
Yes, sir.
Okay. Those who are online are able to understand?
Yes, sir.
Okay. Shall I proceed? Yeah. நீ வந்து அதே பாயிண்ட்ல வரைஞ்சிருக்க, that is wrong. How many of you are bad with surface areas and volumes from your 10th standard? வராதா இந்த சாப்டர் தேவை. ஸோ அதனால அட்லீஸ்ட் கோ த்ரூ த ஃபார்முலா. ஏன்னா what they will do is inside a cylinder there will be a sphere that is immersed. What should be the maximum volume of that sphere? அந்த மாதிரிலாம் கொஸ்டின் இருக்கும். So you need to know what is the total surface area, curved surface area ன்னு தெரிஞ்சுக்கணும். So prepare a table and come. Okay. Shall I proceed? Sure. Right. சொல்லுமா. அது கிளாக் வைஸ் ஆகும். அப்படி எடுக்க கூடாது. ஆஹா, எக்ஸ்ல இருந்து ஆரம்பிப்பேன். இப்படி லைன்ல இருந்து எக்ஸுக்கு போக மாட்டேன். கையெடு சொல்றேன். இது இருக்கா, இப்படிதான் வரணும். நீ சொல்ற லாஜிக் என்னன்னா ஃபர்ஸ்ட் டான்ஜென்ட் வரைஞ்சிட்டு இது ஆன்டி கிளாக் வைஸ் இருக்கு. அப்படி இருக்காது. From x-axis you should turn towards the tangent in anti-clockwise direction. You don't get confused between this anti-clockwise and this anti-clockwise stuff. This anti-clockwise is the angle. This one I used to mark it. Okay, don't get confused. Right? Okay. So shall we try to understand how to apply this? Okay, listen. Suppose I give you a function like this, f of x is equal to sin x, right? F of x is equal to sin x. Check whether the function attains maxima or minima at x is equal to pi by 2. See, though it is 1 point, right? We generally don't say maximum or minimum. It is a mathematical language that is used. So don't worry too much about the plural and singular. Okay. So did you understand the question? There is sin x and you need to check whether the function attains maximum or minimum at which point? At x is equal to pi by 2. Okay. So this is the point pi by 2, right? By graph, I can say it attains maximum, right? Now the question is, how do I use the derivative test to verify whether it is attaining maximum or minimum? So what should happen is, first I need to find what is f dash of I by 2 minus. I need to check the sign of it. Then I need to check what happens with f dash of pi by 2 plus. Then I need to check the sign of it, right? So what is f dash of x? It is, sorry. So f dash of x is equal to cos x. Am I right? Now what is f dash of pi by 2 minus? This will be cos of, observe whenever you have this kind of a thing, no, all that you need to do is you need to write it like this: limit h tends to 0, like how we find the left hand derivative, how we find the left limit. So limit h tends to 0, f of pi by 2 minus h. Okay, so this will be limit h tends to 0, f is cos of pi by 2 minus h. What is cos of pi by 2 minus h? It is Sin h. So limit h tends to 0, it is going to be sin h. Okay. Okay, 1 minute. I'll do one thing here. Let's forget about this so that you will understand things better. Okay. So I'll get sin h. Okay. Now what is f dash of pi by 2 plus? See, this is only an example. Mostly we'll not do using this method. Only for you to understand and explain it. So what is f dash of pi by 2 minus? I got sin h. What is f dash of pi by 2 plus? I'll get cos of, what will you get? Where h is a very, very, very small value. H is, because what are we doing? We are just checking on the left of it. So on the left of it, what is happening? It is having positive value. On the right of it is having negative value. Check what happens when the sign changes from positive to negative. That's why max. Are you able to understand? Yeah. So since the sign of f dash changes from positive to negative, the function is said to attain maximum. Okay. Can make a note of this. Frida. See, the reason why I removed the limit here is, I told you one thing in the beginning. On the left of pi by 2, wherever you draw the tangent. So when I say wherever, no, I need not restrict myself only to the values which are closer to C. So that is why I removed the limit. Okay. Shall I proceed? Yeah? Shall I? Okay, listen to this. Now I told you this method we are not going to use because this first thing, it is very tedious. It's lengthy, right? So is there another way in which we can find the same maximum or minimum? That's what we are going to see. Okay, now make a note of it. First derivative test to find maxima or minimum. Okay. So what you will do is, if you observe the graph in this way and in this way, right? So here, what is the function attaining? It is attaining maximum, and here it is attaining minimum. In both the cases, you will draw this with respect to x-axis. Am I right? So here it is going to be x, and here it is going to be y. Now the question is, keeping this point C in mind, we saw what happens when we draw the tangent on left of C and right of C. But the question is, what happens when you draw the graph, when you draw the tangent exactly at C? So when you draw exactly at C, whether it is going to be for the case of maximum or minimum, in both the cases, f dash of x will be equal to 0. When you write this f dash of x is equal to 0, one challenge that we are facing is, unlike increasing, decreasing, they are clearly differentiated. Increasing means greater than 0, decreasing means less than 0. Here, what is happening? For both, we have the same condition. That's a confusing thing, right? So by doing this, what you can, first thing, what you can find out is, on solving this equation, we will get the value of x is equal to C1, C2, so on till Cn. I'm assuming there are n maxima. You will get, let's say, n different values, right? But what is the challenge? You don't know whether at the point C1, C2, C, so on till Cn, here the function is attaining maximum or minimum. For that, what we need to do is, we need to go with the second derivative test. So for second derivative, what you will do is, you will differentiate the same function. You will differentiate f double dash of x, right? And then what you will do is, you will substitute each of C1, C2, so on till Cn. Right, what are you going to do? You are going to substitute these values and see. After substituting, there are two cases that we need to take into consideration. After substituting, if f double dash of that particular C value, here when I write C, I'll call it as Ci. If that particular f double dash of C value comes out to be greater than 0, listen to this carefully. If it comes out to be greater than 0, then Ci is said to be the point of minimum. Whereas if f double dash of Ci comes out to be less than 0, then Ci is said to be a point of maximum. Are you able to understand? Right? So there is a reason for this. I'm not showing you the derivation for this. This reason is proved using the first principle of derivative. Okay, I'm not showing you the reason. You can make a note of this. There will be some values of C for which you will have maxima, some values of C where you will have minima. So what you will do, you will substitute each value and see. See, for example, you are getting 1, 2, 3, 4, 5. Okay, you are doing f double dash. You are substituting 1, 2, 3. You are getting greater than 0. Upper meaning another. At 1, 2, 3 gitta minima on the 1, 2, 3 gitta minima means the function has dipped downwards. Nature the maximum. Okay. So these points are there, no, that C1, C2, so on till Cn. These points are said to be critical points. So these points are said to be critical points. I hope those who are online are able to understand.
Yes, sir.
Yes. Shall I proceed? See. Proceed. Okay. Yeah. See, now the question is, f double dash of Ci is greater than 0, f double dash of Ci is less than 0 for minima and maxima respectively. But what if f double dash of Ci also comes out to be 0? Then this point is called as the point of inflection. It's called as the point of inflection. Okay. Now what I'm going to do is, I'll show you an example of how to do this second derivative test and find out. So I'm going to take the same example of sin x. But this time, I'm not going to ask you to verify whether you have maximum or minimum. Rather, I'll ask you to find where does it have maximum, where does it have minimum. Okay. So, shall I do that, Anshu? Okay. Yeah. So, listen. If I take f of x is equal to sin x, what am I doing? F of x is equal to sin x. I'm asking you to find where this function attains maximum or minimum. So for maxima or minima, what is the first step to be followed? For maxima or minima, find f dash of x. F dash of x is cos x. Then what do? You equate it to 0. First derivative is always equated to 0. When cos x is equal to 0, what are all the values of x? What are all the values? What will be the value of x? It will be 2n plus 1 pi by 2. It will be odd multiples of pi by 2. So it will be 2n plus 1 into pi by 2. If you write n pi by 2, what will happen is, I'll tell you what is the mistake. If you write it as n pi by 2 and you substitute 2 here, 2 pi by 2, 2 and 2 will get cancelled. Cos pi is not 0. Cos pi is minus 1. So it is not n pi by 2, it is odd multiples of pi by 2. Now, having said this, I'll take 4 points within the first complete cycle. That is between 0 to 2 pi. So x will be equal to pi by 2, 3 pi by 2. Okay, I'll get only 2 points. So pi by 2 and 3 pi by 2. Now I'm going to do f double dash of x, meaning I need to differentiate this function. What do I get? Minus sin x. So I'll find f double dash of pi by 2. When I substitute this value, what do I get? Minus 1. What is f double dash of 3 pi by 2? It will be plus 1. Because sin 3 pi by 2 is minus 1. Minus of minus 1 will become plus 1. Okay, what did I say will the second derivative test help us to decide? When the second derivative is less than 0, it is a point of maximum, and this is going to be the point of minimum. Is that not what is happening with the graph? This is pi by 2, 3 pi by 2. Make sense? So at pi by 2 it attains maximum, 3 pi by 2 minimum. Similarly, what will be the other point where it will be maximum? Keep adding 2 pi to it. 2 pi plus pi by 2, 5 pi by 2. 2 pi plus 3 pi by 2, 7 pi by 2. So at 5 pi by 2 maximum, 7 pi by 2 minimum. Then odd multiples, 9 pi by 2 maximum, 11 pi by 2 minimum, all of them. It keeps on going like that. Same thing will happen symmetrically on the left hand side, meaning minus pi by 2, minus 3 pi by 2. Okay. One thing that will happen with respect to this graph is it will get reversed in the left side direction. F of minus pi by 2, what will you have? When you substitute minus pi by 2 here, you will get plus 1. So on the other it will be minimum. That's a graph. Are you able to understand this point? So it keeps changing like this. Be careful with this. Okay. So I hope you could understand this, no? So this is the theory. Now we are ready to solve problems. So tomorrow's class, I'll start with problems. So that doubt. In this step, full away. See, one function eduko. When you are going to check with second derivative test, two step follow up. First is find f dash of x. Derivative of sin x is cos x. Equate it to 0. Okay. Then you need to find the values of x for which cos x will be 0. And then the values in pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. Odd multiples of pi by 2. Now I took only one cycle between 0 to 2 pi. Adila I got two angles for which cos is 0. Okay, this mind la vechukko. These points are called as critical points. If a second this will not help me to decide whether it is maximum or minimum. Yeah. Maximum and minimum renduthukkum condition f dash of x is 0. So I need to do the second derivative test. Your option is illa. So I will differentiate this function again. When I differentiate cos x, I get minus sin x. So in the minus sin x, I have these two critical points. One substitute panni paapa. So when I substituted pi by 2, I got minus 1. So minus 1 negative or positive? So negative na enna sonna second derivative test. Previous page lo edhiruppa f double dash of ci. Negative na. Maximum another at pi by 2 it is attaining maximum. Mala podula. Adhe mari 3 pi by 2 when I substitute I get plus 1. So f double dash of x the negative positive or the minimum. Adha nadakku. Puriyudha? So that is all you need to do. Idan chapter eda. Only challenge is in the chapter what is the toughest part is you will not be given the function. You need to frame the function and do it. And definitely you will get a long answer question from this topic. For a question definitely for sure. It can be a case based question or it can be a subjective question. As I told you, all that you need to do is you need to know the surface areas and volumes properly. If you don't also, I'll give a table down. Don't worry about it. But only it is good. You will not be dependent on me. You need to frame the equation. You need to know how to solve it out. That part I'll teach you. Sorry. Yeah. Any other questions?
No, sir.
All clear? Yeah.
Yes, sir.
Here, we'll wind up.
Yes, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.